Hello and welcome to Warrior. I'm Chris. We're very glad you're here. We're bringing you something cutting edge and very new, a series on counter drone technology. Certainly, the threat can't be underestimated with the Red Sea, Ukraine, what's happening with potential adversaries across the world. This is being brought to you by Warrior Maven, and an amazing partner, a UK based think tank called CUAS Hub, Counter Drone Specialists. They're part of SAE Media. They work on analysis, writing, and exploration of all kinds of drone technologies. We'll be talking to some of the most cutting edge decision makers and weapons developers and experts in this field. And we can tell you our amazing sponsor, the industry powerhouse Elbit America, is sponsoring this series. Hello, welcome to Warrior. I'm Chris. AI-enabled drones destroy Russian bombers. Swarm drones are threatening bases all across the U.S. There's a Golden Dome, a U.S. effort to defend the homeland against the fast-changing drone threat, AI, high-tech. We are joined now by one of the top experts in this field, specific to drone defense, U.S. Army Pacific's Chief of Fires, Colonel John Harvey. Sir, you're an expert people want to hear from. Thanks for your time.
Hey, sir. Thanks much. Really appreciate the opportunity to join you today.
Absolutely. Well, this is part of our counter UAS series. And one of the first questions I want to ask is, how can a swarm be stopped? Kamikaze drones like Switchblade have been destroying Russian tanks. There are all kinds of threats with them, either blanketing an area with ISR, becoming munitions themselves. Is there any defense?
Yeah, that's a great question. I'll tell you, it's one that keeps probably just about every military leader of any kind, from company commander all the way up. I mean, I was a brigade commander not too long ago and had my unit out in the field doing our training, and we were constantly putting ourselves against drones and not even the swarms. Right, we're a little bit before the swarm technology. It's just this is the modern battlefield. Whether and Ukraine is kicking out all these studies and kicking out all these lessons for us as we try and figure out what technologies, what capabilities, what's the difference between localized protection versus area protection, and what kind of systems do we need, and how do you do it at a cost effective rate, right? I mean, that seems silly, but at the same time, you don't want to spend a $1 million missile at a $20 drone. And so, not thankful for what they're suffering, but thankful that we have the opportunity to learn and bring these lessons back. And that's where you're seeing, I don't know, you may have seen the article just a couple of days ago. There's some great innovation going on in this space. There is a test going on right now with, I believe, 3rd Cavalry Regiment on a site that actually sits on a soldier's weapon. And this site is so advanced with AI and other technologies that it will do drone tracking and let a soldier through their M4 weapon with a 5.56 out to 600 meters guarantee take that drone down. Now you're talking swarms and multiples, but I mean, if you come all the way down to the very, very unit level protection, and then you start layering on, just like we're doing with the Defense of Guam effort, as part of that government effort, it's how do you layer capabilities against incoming missiles, against level 3 drones, level 2 drones, level 1 drones, down to unit level protection. That concept and the work that we see coming out of industry to help us with this is what's really going to get us there.
I'm glad you mentioned AI, Colonel, because this whole idea of pairing sensor to shooter, is there an apparatus or an infrastructure that can take otherwise disparate pools of incoming sensor information, translate them, aggregate them, organize them, and then make those recommendations, perform the analytics, decide in this particular scenario, we recommend a laser or EW or perhaps a kinetic interceptor? How far along is AI in terms of enabling that high-speed decision-making in milliseconds?
Yeah, and there's a ton of progress here. And, so the IBCS, Integrated Battle Management System, Battle Command System, excuse me, had to get a phone a friend there. So that system really is the backbone architecture that we're developing, and it's developed. It's now in prototype and fielding of how do we take any sensor, any shooter, and when you take any sensor, and this is what gets to your question, right? That's an air defense developed system, but the idea is that you can grab any sensor out there, integrate it into the network, and then push it out to the shooters, whether that's a high power microwave, whether that's a field artillery unit, whether that's an air defense unit, whether that's a probably not going to get down to the soldier with the drone buster per se, that, that comms link probably doesn't exist, but at the area protection level, this is where we are trying to go from a capability standpoint. And like you said, AI is the absolute backbone that's got to run through this. A human, as awesome as we are, just does not have the mental compute capacity to make those decisions quick enough at speed and pace. And so being able to leverage, human machine pairing, being able to leverage sensor management, and more importantly, data routing, right? This is a huge area where AI is able to get into our networks and help us. It moves this information through the most effective way in the smallest packages possible. And then that's how we go super fast. It's not soldiers on the radio saying, hey, I got this coming, I got that coming. It's now data moving at its own fastest rate to get to that shooter. And that's where we'll go.
With AI-enabled machines able to make those determinations, as you talked about, in milliseconds, is there a space for possibility? There was in that Pentagon essay about out-of-the-loop autonomy, essentially the idea that for purely defensive purposes, AI-enabled systems could recognize, take out mortars, drones, incoming threats in milliseconds, of course, respecting the core doctrine that humans in the loop on lethal force.
Yeah, so you're talking about an area that we've done a little bit of work here, not specific to any particular target set, but we've done some work here at USERPAC on this idea of, where can you put an artificial intelligence agent inside the loop to be, and obviously you have to do some training. You've got to, I like to use this example when people talk about putting an AI algorithm into an architecture, into a network. It's a living thing, right? So when you put that agent into the network to help you make that identification, make that friend or foe, you still have to train it, you have to maintain it, you have to care for it, you have to, do the maintenance on the algorithm, you've got to be constantly updated, because any AI, large language model, what does it need to survive? It needs more language, right? It needs more information, more data. And so when you're talking about how do we do this and get a human, an AI loop end to end, I really think it's through this thought process of, where do you put agents inside of the architecture that are trained and maintained by a human? So when you get back to that risk calculus that you mentioned, when you talked about the human owns that, that shoot, don't shoot, I would propose, and, do a little bit of work on an article on this right now of, well, what if you put that human way, way far left on that loop, in the sense that if you're talking about target identification, that you have a team of governmental folks who are responsible with the caring, feeding, training, maintaining of that agent, monitoring of that agent, testing of that agent, evaluating of that agent, checking the drift, checking the, and so the human is actually behind that agent, making sure it's functioning the way it wants, so that leaders can then trust that agent to do what it needs to do. Because at your point, if you're going to go to a shoot, don't shoot that is, nearly completely automated, you still have to reduce the risk of whether or not that agent is behaving in the way you anticipate and need it to behave. And again, stand by for the article here in a couple of weeks as we finish that thing up.
Wow, I hadn't heard of that before. What a way to anticipate the zero trust predicament and the problem with AI reliability. You often hear that AI is only as effective as its database. If the data is not tagged, how can it integrate and make sense of, through context, information that's not part of its pre-existing database? And with you talking about how the man-machine interface, humans helping to oversee and ensure that process can increase reliability, that's a massive risk reducer when people look at the threat equation and the possibility of a false positive and the possibility of AI firing at the wrong thing. And you sounds like you've got a real solution to address that, which strikes me as very novel.
Well, I don't know if it's a solution. I'll go as far as say it's a concept. I mean, we have done some work here on developing agents. We have currently been training an agent to serve in the doctrinal thought process of a field artillery targeting warrant that does a lot of the side and execute functions. So we've used that as kind of an experiment of, where could we put an agent? We're working on some other network agents, and really INDOPACOM, provided us the backbone to do this through some application software, artificial intelligence software. So I'm super excited about where this is going, because like you said, I think this really opens up this idea of, because right now my experience says leaders want to make sure they've got that last final call, and that's how they're willing to accept the risk of AI whether it's computer vision, whether it's large language model, whatever. But ultimately, somebody's got their finger on the button. But this idea of move that finger on the button all the way back to the development side, the monitor and build and function, then our leaders aren't as worried about whether or not their fingers on the button, because they know that we have built all the right things and we are monitoring. Most important, monitor. This goes back to that AI algorithm is a living, breathing thing that you have to, just like a child, right? You have to put your hands and you have to care and you have to hold and mold and train and teach. And if we just throw it out into the wild, an algorithm out in the wild, then eventually it will starve, and then it will not function the way you want it to. And that's why I'm trying to explore this thought process of moving that risk to the left in the way we train, build, and create them.
Well, this is potentially life-saving if one looks at the difference between an incoming salvo of missiles or attacking munitions and the ability to knock them all out in milliseconds, or the ability to have that sensor to shooter curve, that decision about countermeasure take several minutes. That's a massive tactical difference. So if there's a way to really improve reliability, yet shorten that curve to milliseconds, that's tactically extremely significant.
Yeah, no, you're absolutely right. And then when you start pairing that with platform-based innovation that we're doing, right? So, there's discussion about how do we create autonomous launch vehicles? How do we create tethered launch vehicles? How do we move our air defense posture far, out here in the Pacific? How do we move that posture farther forward so that we force the enemy to go farther backwards because they're more and more under the threat? And this is, kind of the base value proposition of the Army in the Pacific, right? The more we have posture forward, the more that we campaign our equipment forward, the more we force the enemy to change their thought process. So if I can combine technology and timing and tempo with new and innovative platform systems and posture, now I've created our own, the anti-access aerial denial is the term du jour for our ability to get up underneath, the air defenses of an adversary. Well, what if we can create that for ourselves and put them under ours by posture with systems combined with speed of technology? And now you've created a rubric that they have to solve.